Okay, I welcome you all to this class. I'm Ms. Vandana Gupta, Assistant Professor of Mathematics. So today we are going to do the section 2 statistics in that unit 4 elementary probability theory. So this unit has got two subunits. One is probability theory and the second part is, or the second subunit is random variable. So today we are going to start with the probability theory. Before we actually begin with the introduction of probability, let me give you one simple example. See, if there are three students and to each one of them, these are the three students, to each one of them, I asked to perform an experiment. The experiment is, I will give them a vessel filled with water and ask them to put it on a stove or heat the water. So what will happen? To each one of them, I'm giving a vessel filled with water and asking them to heat the water. Then I'm going to ask them, what is the result when you heat the water? So everybody knows that when you heat the water is in the liquid form, correct? Water is in the liquid form, and this water will get converted into steam. Steam, which is what? Which is in the gas form. If water is given to A or to B or to C, anyone, and if they perform this experiment, they boil the water or they put the water on stove. In each one of the case, the water will start boiling and it will convert into steam. Anyone perform the experiment, the result will be same. Similarly, if the water is a bowl in with water is kept in a fridge, then it will get converted into ice. As you know that at 0 degrees centigrade, ice water gets converted into ice. So from liquid, it will turn to solid form. Okay. So these type of experiments where you know what is the result of the experiment, they are called as scientific experiment. You might have done some experiment in your school days in science laboratories. So each one performing the experiment, the result or the outcome of the experiment will be same. Such type of experiments are called as scientific experiments. There are some other type of experiments where the outcome or result of the experiment may not be same. For example, if I give a coin to these three students and ask them to toss the coin, you know that the coin has got two faces. One is called head and the other one is called as tail. It may happen that when the student A is tossing the coin, he is getting head on uh, the uppermost face of the coin which he has tossed, or B is getting tail, or it may happen that C is again getting head. So different people are getting different results. Similarly, if you throw a dice, you know what is a dice. Each one of you might have in your childhood or in school days, you might have played snake and ladder or ludo. Okay, so those type of games are played by throwing a dice. You know what is a dice? A dice is it's like a cube which has got 6 faces, and on each face a number is written, and a number is not repeated. Okay, a number cannot be written on two different faces. So a number from 1 to 6, 1 2 3 4 5 6, there are 6 faces and the numbers 1 2 3 4 5 6 are written on that. So if I give this dice to student A and ask him to throw, it may happen that he gets 1 on the dice, on the uppermost face of the dice. Student B may get 5, or student C may get 6. So each one of them may get different result. Okay. So such experiments where the outcome or the result of the experiment is not fixed, such experiments are called as random experiment. And our whole theory of probability is based on these type of experiments, random experiments. One more example I can give you. You know, playing cards, there are 52 playing cards, right? If I shuffle them properly and ask student A to select one card out of this pack of 52 cards, he may get a red colored queen card or hard card. The other person may get a black card. Third person may get a king of diamond. So different people may get different cards. So again, the result of this experiment is also not certain. You may have plenty of examples like that. One more example, suppose I take a bowl and in that bowl I fill that bowl with different um, colors ball, small balls with different colors. I place in a bowl, I shake that bowl, and I ask these three students to close their eyes and just pick one ball out of that. It may happen that student A get yellow color ball, student B get red color ball, and student C may get some other different color ball. So the result of this experiment may not be same for different people. Okay, so such experiments are given a name called as random experiment. So we'll define here. What is random experiment? An experiment whose outcome or result is not certain is called a random experiment. Examples of random experiment: tossing a coin, rolling a dice, or selecting a card from a well shuffled pack of 52 cards. Or the example which just now I gave you, picking one ball from a box containing different colored balls. Okay. So these are some of the examples. You may have many more such. Now, what is the meaning of sample space? See, though we see that the outcome of random experiment is not fixed, but definitely we can find out what are all the possible outcomes of the experiment. So the collection or set of all possible outcomes of a random experiment is given a name which is called as a sample space. And it is denoted by capital S. So what is sample space? It is the set of all possible results of an experiment. And then the possible outcomes of the random experiments are called as sample points. The number of sample points in the sample space of an experiment is denoted by n of s, n for number. So number of points in the sample space. Let me explain you this with the help of example. So as I told you, let us take the very first simple example of tossing a coin. So this is a random experiment because its result is not fixed. So the first example we will take, experiment of tossing a coin. You know that when you toss a coin, what will be the possible result? Either you will get head or you will get tail. If I denote head by H and by T I mean tail, then these are my possible outcomes, either H or T. I will write down them in the form of a set, and this set I will call as sample space. So what is sample space? It is the set we always write in the curly bracket. It is the set of all possible results of an experiment. So here the experiment is tossing a coin. What are its all possible results? Either it will land into H or in T. So sample space of this experiment is H and T. H and T are called as sample points. And how many sample points are there in S? 2. 1, 2. So we will say that n of S is equal to 2. Okay. Because S contains two members, H and T, which are called as sample points. So n of s is 2. Let us take another experiment. Throwing a dice. Let us find out what are the possible outcomes of this experiment. You know that when you throw a dice, what are the different possibilities you may have? Either you may get 1 on the uppermost face, or you may have 2 or 3 or 4, 5 or 6. These are the only possible results of this experiment. So these are called the sample points. And how many sample points are there in S? It is 1, 2, 3, 4, 6. So we will say that number of sample points in S is 6, or number of members in S. Okay. So this experiment, the sample space is containing 1, 2, 3, 4, 5, 6. So n of S is 6. Let us take the example of tossing 2 coins. Suppose I want to write down the sample space of tossing 2 coins. Third experiment I am taking 2 coins together. If you are tossing 2 coins together, what will be the possibilities? You have to list all the possibilities. Okay. So it may happen that both are landing in H and H, both are giving you head, or first one in head, the second one in tail, or first one in tail, the second one in head, or both in tail. These are the only 4 possibilities. So what is number of, and this I call it as sample space. So here n of S will have 4. N of S will be 4. So number of sample points in S will be 4. Okay. Tossing 1 coin, S will be H and T only. So number of points, number of members in S will be 2. If you are tossing 2 coins together, then the sample space will contain 4 sample points. So n of S will be 4. Similarly, if you are rolling 2 dice together, or if you are throwing 2 dice together, what will be the possible results of that experiment? Let us list down all of them. It may happen that you have to list all possible. Okay. So it may happen that the first dice is on the first dice, the number 1 has come on the uppermost face. And on the second dice also 1. So this is one outcome, 1, 1. Next, you can have 1. The first one on the uppermost face of the first dice, it is 1. And on the second dice, it is showing 2. Or it may happen that 1, 3, 1, 4, 1, 5, and 1, 6. Or the first one is showing 2 on the uppermost face. The second one is showing 1. Or both showing 2, 2. Or 2, 3, 4, 2, 5, 2, 6. Or you may have 3, 1, 3, 2, 3, 4, 3, 5 up to 3, 6. Similarly, first one 4, second one 1, 4, 1, 4, 2, 4, 3, 4, 5, 4, 6. Then 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. And finally, the first one in 6, second one 1, and so on 6. If you count, this is the sample space. If you count, number of points in sample space will be 36. Okay. So this is what I have tried to show you here. Okay. See, sample space is the set of all possible outcomes of a random experiment, and it is noted by capital S. The outcomes are called as sample points, and number of sample points is denoted by n of S. Let us see here. Examples. Sample space of the experiment of tossing an unbiased coin is given by S equal to H and T. So n of S is 2. Sample space of experiment of rolling a fair dice is given by S equal to 1, 2, 3, 4, 5, 6. So n of S is 6. Then sample space of the experiment of tossing two coins together, that the sample space will be HH, HT, TH and TT. So N of S will be 4. Similarly, sample space of the experiment of rolling two fair dice together will contain 36 sample points. And if you are taking this sample space of selecting a card from a well shuffled pack of 52 cards, if you are asked to just select one card out of a pack of 52 cards, you may have any one card in your hand. So it can be selected in 52 different ways. So N of S will be 52. Though I cannot write down in the form of a sample space because 52 means it can be 13 red card of 13 hard card, 13 diamond card, 13 spade card, or 13 club card. And in that also 1 to 10, then Jack, Queen and King. So there will be 52 choices. So number of points, sample points will be 52. So we have seen what is sample space. It is the set of all possible result of an experiment. What is an event? An event is a set of particular outcome of a random experiment. That is the difference between sample space and event. Sample space is the set of all possible outcomes, and event is a set of particular type of outcomes. So event is a subset of sample space. Let us see what is the meaning of that. And this event is a subset, meaning what? It is a part of sample space. Okay. If S is a sample space and we denote the event by A, then A is a subset. This is the symbol for subset. A is a subset of S. So by diagram, I have tried to explain you. If this is the sample space S, this rectangle, then this oval shape, which I have written here, A, it is a part of this. So A is an event. A is an event and S is a sample space. A is an event and S is a sample space. What is the difference? Sample space is the set of all possible outcomes and A is a set of particular type of outcome. A will be a part of S. So A is a subset of S. This is a symbol which we use for subset. Okay. I will explain you with the help of one example. Let me go to the slide here. Suppose I take the experiment of throwing a dice. I know what is the sample space of this experiment. Sample space, as you know, it is the set of all possible result of an experiment. What is my experiment here? My experiment is throwing a dice. Okay. Let me explain you what is the meaning of event from this example. Okay. So what is my experiment? I am throwing a dice. I know what are the possible outcomes. Let us raise them down. So all the possible outcomes are this. I know that this is my sample space and I also know that number of points are 6. So S contains 6 members. Now, I define a set A as an event as in throwing a dice, let my event event A be getting an odd number. Getting an odd number. When I throw the dice, getting an odd number on uppermost face of the dice. What is the odd number meaning? The number which is not divisible by 2. That is odd number. So what is my event here? When I throw a dice, if I get an odd number, I say that my event has occurred. So what points will come in A? 1 will come. Yes, 1 is an odd number. 2, no, 2 is an even number. So 1, 3 and 5. So this is my event. How I have defined the event? Getting an odd number. So from 1 to 6, if I get 1, yes, my event A has occurred. If I get 3, yes. If I get 5, yes. So this is my event. What are the number of points in this event A? They are 3. And this A is a subset of S because all the members of A are in S. A is a part of S, correct? So A is a subset of S. I may have many more such events. I can have one more example of event. This is first example. I may have another example in throwing a dice, getting an even number. That can be called as an event. I can denote it by 2. I'm sorry, by B. So what sample points will come in that? 2, 4, and 6. Because these are the even numbers. What is n of B? Here also n of B is 3. And I know that B is a subset of S. So event is a particular type of a set of particular type of outcome. What particular type here? Getting an even number. I can have many more events like that. I can have another example that my event I can define as throwing a dice and getting 6 on the uppermost face. That can be called as an event. I denote it by C. So what will be my event C? It will just contain 6. What will be number of points in C? It will be 1. So when I throw the dice and if I'm getting 6, that means my event C has occurred. So in this way, event is any subset of the sample space. Similarly, in the example of tossing a coin, here also you can define event. Suppose I am in the experiment of tossing a coin, then I know what is my sample space. If I toss a coin, then the sample space will contain either contain H and T, because these are the only two possible result of this experiment, correct? So suppose I take next example, tossing a coin. I know what is the sample space of this experiment. What is the sample space? Head and tail. I know n of S is okay. Now see, I can define my event A as, I can define event A as in tossing a coin getting a head. That's my event. So I know that A is a subset of S. Yes. And what are number of points in A? It is 1. So in event, I am taking a particular type of result, getting a head. Similarly, I can have another event, getting a tail. So this B is also a subset of S. And how many points are there in B? So that is the difference between the sample space and an event. Event is a part of S. It is not the set of all possible results. It is the set of some particular type of result. Okay. Now, if A is an event of S, that means A is a subset of S, then how can you relate number of points in A and number of points in S? Look at here. S is a bigger set and A is a small part of it. So A में number of points in A, मतलब A में जितने member होंगे वो S में जितने member होंगे उससे कम होंगे या तो equal होंगे, है ना? So we can say that, देखो यहाँ पर n of A 1 है, 1 is less than n of S. Okay, because subset will always have less number of less number of members than the bigger set. Okay, so this is what I have written here. See here, examples of event. The first example what I have given, in an experiment of rolling a dice, getting an odd number on the uppermost face of the dice is an event. What points will be there in that event? 1, 3, and 5. And what are the number of points in this A? It is 3. Similarly, in an experiment of this rolling a dice, the same experiment, getting an even number on the uppermost face of the dice, that also can be called as an event. Let it be denoted by B. So B will contain what? Even numbers. So 2, 4, and 6. So n of B is equal to 3. Okay. And n of S is 6. So we can say that n of A is less than or equal to, see here, number of points in the sample space is 6, because we know in the experiment of rolling a dice, this is your sample space. Okay. So n of S is 6. So n of A is 3. So n of A is always less than or equal to n of S. Look at here. 3 is less than 6. Okay. So we have seen what is sample space and what is event. Now let us see, there are different types of events. So look at the first one, that is called an impossible event. What is the meaning of that? An event which can never occur is called an impossible event. जो कभी occur हो ही नहीं सकता है, ऐसे event को हम impossible event बोलेंगे. And it is denoted by this symbol, which is read as phi. Okay. For example of impossible event. In an experiment of rolling a dice, getting a number 0 on the uppermost face of the dice is an impossible event. मतलब क्या? अगर मैं आपको बोलूं आप रोल करो डाइस को या थ्रो करो और my event is getting 0 on the uppermost face of the dice, will you ever get 0? No, क्योंकि डाइस में 6 ही फेस होते हैं और उनमें जो नंबर लिखे हैं वो 1 से 6 तक लिखे हैं, 0 नहीं लिखा है, तो कभी भी मुझे 0 नहीं आएगा. तो that event is an impossible. Understood? Similarly, if I throw a dice, getting a number 7 or 8 or 9 or any number bigger than 6, it will never occur because dice pe number 1 se 6 tak hi hai. I hope you are understanding. So an event which can never come, never occur is called an impossible event and it is denoted by 5. So अगर ये कभी occur ही नहीं हो सकता है तो इसमें कोई भी member नहीं होंगे, empty set होगा ये. तो if I ask you how many members are there, इसमें कोई भी member नहीं है, मतलब 0 है. तो n of 5 मतलब number of sample points in the empty or the impossible event is 0. So it is impossible. There will not be any point in that. Okay. So that is the meaning of impossible event. First one. Let us see the certain event. How I have defined the certain event. Certain event is an event which will surely occur. वो आएगा ही, occur होगा ही. ऐसे event को हम बोलते हैं the certain event. For example, if I throw a dice and I say that my event is getting a number from 1 to 6, तो वो होने ही वाला है. जब मैं अगर डाइस को थ्रो करूंगी तो मुझे जो नंबर आएगा वो 1 से 6 के बीच में ही होगा, 1 to 6 है ना, because I know that, so it is going to happen. I may get either 1 or 2 or 3 or 4 or 5 or 6. Okay, so that is sure to happen. तो ऐसे को बोलते हैं हम certain event. So every set is a subset of itself, you know that. Therefore S is a subset of itself and S is called a certain event. यानी sample space जो खुद है ना, that is the sample space S of throwing a dice, this, it itself is an event. I may call it as an event also. F is a subset of S. Every set is a subset of itself. Okay, it is going to happen. So certain event is an event which is surely going to happen. Examples of impossible event तो मैंने दे दिया आपको. Example of certain event means S itself. Now let us see the third one. Complementary event. What is the meaning of complementary event? If A is an event from the sample space of an experiment S, then non-occurrence of event A is called complementary event of A. I'll explain you this with the help of example. And it is denoted by A bar or A dash or A complement. For complement, you may use any notation. Okay. Either you use, different books are using different symbols, A bar or A dash or A, and on the top of A you write C. A, C for complement. Now Phi, this is the technical definition. What you understand from this, suppose this is my sample space and A is an event here. So non-occurrence of A मतलब A अकर नहीं हुआ है, यानी A के बाहर का चीज अकर हुआ है. ओके, जो A में नहीं है, that is called A complement. So इसलिए this portion जो A में नहीं है, मतलब the outside of A, that is my A complement. Okay, so let us see this with the help of example. Suppose I am in the experiment of rolling a dice. Okay, and my event A is getting an odd number. A is 135. So what will be the complement of A? Complement of A will be which is not in A. तो A में, this is my sample space S. Okay, A में क्या नहीं है वो A complement में जाएगा. तो 1 is there in A, so it will not come in A complement. 2, yes. अगर मैंने डाइस को थ्रो किया और 2 आया, इसका मतलब मेरा इवेंट A नहीं आया है, नॉन अकरेंस ऑफ A. यू अंडरस्टूड? तो अगर 2 आएगा डाइस को फेंकने पर, तो दैट मीन्स event A has not occurred because my event A is what? Getting an odd number. 2 is not an odd number. So 2 will go in A complement. Similarly, 4 will go in A complement. 6 will go in A complement. तो कॉम्प्लीमेंट का मतलब है जो ए में नहीं है, नॉन अकरेंस ऑफ ए. Okay, so A complement is 2, 4 and 6. Similarly, I have given you one more example. Let B be an event of getting a number divisible by 3. The experiment is same, throwing a dice. I am calling my event B as getting a number which is divisible by 3. Now, इनमें से कौन से नंबर 3 से डिविजिबल है? 3 है एंड 6 है. तो 3 से डिवाइड होते हैं. डिविजिबल बाई 3 मतलब जो 3 से डिवाइड होते हैं. तो 3 होता है और 6 होता है. तो my event B is 3 and 6. Now I want to write down what is the complement of B. Very simple. क्या करना है आपको? जो B में नहीं है वो उसके कॉम्प्लीमेंट में जाएगा. तो B में क्या नहीं है? 3 और 6 को छोड़ दो, इसको और इसको छोड़ दो, ये B में है. तो क्या बच गया? 1, 2, 4 and 5. 1, 2, 4. So that will be in the complement. I hope you have understood. Okay. So complement का मतलब होता है non set of if A is any event in the sample space, then non-occurrence of event A is an event which is called complementary event of A, and it is denoted by A bar or A complement. So I have tried to explain you with the help of example here. So suppose this is my sample space S. 1, 2, 3, 4, 5 and 6. And what is my event A? It contains 1, 3 and 5. This is oval one. So this is my event A. So what is outside A? जो A में नहीं है वो 2, 4 and 6. So these 2, 4 and 6 will form my A complement. Look at here. A complement is 2, 4, 6. Similarly, this also I can मतलब show you with the help of example. 1, 2, 3, 4, 5, 6. This is my sample space S. What is my event B? It contains 3 and 6. This is my event A. Okay. So जो A में नहीं है मतलब A के बाहर क्या है? A के बाहर मतलब outside A क्या है? 1, 2, 4 and 5. So that is my B complement. I'm sorry, this is not A. We are calling it as B. Okay. So B complement is 1, 2, 4, 5. जो B में नहीं है. Okay. So we have seen today three different the concept of random experiment. What is sample space? What are sample points? What are events? And what are different types of events? In that three types we have seen today. One was impossible event, which can never occur. Which is second one was certain event, which will surely going to occur. That is set S itself. And third, complementary. So A and if it is the sample space outside of A, that is A complement. Okay, this much we have done today. So this much is a prerequisite to start with the definition of probability. So tomorrow we will start with the technical definition of probability. So tomorrow when you come for the lecture, you just have a look on this today's PPT and the recording which I'm going to send you. So thank you.